Hot chocolate, Azure Cosmos DB. Dapper. Entity Framework, Power Tools. Netology Suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lanson.
Martha Vickers.
.net data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .net Data Community Stand-Up.
Yep, we're here again, another .NET Data Community Stand-Up, hoping to be much more prepared as always and doing everything at the last minute. But you know why? It's because they didn't have paprika Pringles at the co-op, and so we had to make an extra trip to Sainsbury's so my wife could get the paprika Pringles. So I'm blaming all the fact that I'm not prepared on that and not the fact that I spent the last 2 weeks saying, we're going to do this and not prepared.
That's absolutely awful. I don't know how,
I know.
how you got through that.
Anyway, so yeah, a lot of today is going to be me stepping through code, internal code in EF Core, and talking about it, answering your questions. I would have liked to have been a bit more prepared, but hopefully it will go okay anyway. And we're going to talk about the internals of model building, so everything that happens from discovering your DB sets through configuring them, running conventions, all that kind of stuff, down to finalizing the model so that you can use it to run your queries and everything. And okay, so yeah, paprika is good. Okay, let's start with State of the Unicorn. I have to just switch to this view. No, not that view. I have to add this to the stream and then go to this view. There we go. Yeah, professional. We know how to do this. Okay, so what's going on? So EF8 Preview 3 is on NuGet. We didn't have any major new features in this. There's a few small things worth mentioning. So we've optimized updating for a single JSON property, a single element in the JSON property. We do less SQL on that now, which is great. You can now use JSON columns in compiled models. So we didn't in EF7, we didn't allow you to use JSON columns in a compiled model. It got scoped out at the end of the release, so that's now available. Shay has been working on this for like a year, and it finally got merged. So we have fewer parentheses. You want to talk about this, Shay?
Yeah, I've not been working on this for a year. That would have been very, very sad. This is an issue that just took along, just sat in the backlog for a while. So this is basically work that optimizes the parentheses that we put in the SQL that we generate in EF. Parentheses are very important and also very complicated to know exactly when you need them and when you don't need them. If you get it wrong, then you don't put parentheses and you get the wrong evaluation order, and there's a subtle bug with data not being there. But on the other hand, if you put all the parentheses, then your SQL becomes unreadable. And we have a goal at EF. We want to generate lovely SQL that all you guys will enjoy looking at and be able to parse and understand as if you yourself wrote it. So this basically significantly improve the quality of the SQL by putting parentheses exactly where they're needed and not more. So that's that.
Good stuff. And we also basically removed a restriction that we had, so you can now do set operations, union, concatenation, all that kind of stuff on non-entity projections, even when they have different facets, which was something that a few people asked for. Okay, and EF course 705 patch release, which I think has 5 bug fixes in, so some small amount of bug fixes that are important for 7 is on NuGet as well. Jorchen, our PM, has created this intro video, how to use SQL Server with C# and .NET. That's on YouTube, and it's 6 minutes, so it's very different from these internal things, which go on for like an hour and a bit sometimes, and it's directed at people who are just getting started. And what this video shows is how you can access SQL Server either using Entity Framework Core or using Dapper or using ADO.NET. And so Jorchen covers all 3 of those different scenarios, just very basic, quick 6-minute video. And this is kind of a new thing we're trying to do, where we want to keep doing this kind of content, where we go deep into things. But if you're getting started, then sometimes it's hard to even know where to go. So good stuff there. Okay. I clicked on the link. Sorry, hang on. I didn't mean to do that. What I meant to do was just go to the next page. So progress on. So we're making some progress on the value objects. It's been back and forth on the discussion. It's beginning to look a bit like complex types in the old EF6 stack now. But Andrew is working hard on that, and we're talking about how it interacts with JSON objects and all that stuff. It's surprising. It's a simple thing, and it's surprisingly complex, all the interactions it has.
That's why they're called complex types, Arthur.
Yeah, exactly. Andres also, before that, he completed the compiled relational model. So we have a compiled model for what is the EF model, the conceptual model, if you like. But then we also build this simpler relational model, which is specifically for relational providers and actually says what's happening on different tables. And so rather than being focused around the entity types, which may be mapped to 1 or more tables, it's focused around the actual relational concepts. So this is good in of itself, but it's also a stepping stone to the AOT work we're needing, because we need to have a compiled relational model for that. So that's another stepping stone for that. And then Shay is working on this big thing for contains that we probably won't talk about today. It's got a lot past contains. It's some really cool translation stuff. Do you want to mention, like, in
Sure.
a sentence?
It's a super secret project. No, not really. Basically, this is about primitive collections. That's the title here. What it means is that you will be able to have, for example, an int array on your, as a property on your columns, and and that would be automatically serialized for you into JSON, into a string property in the database in most places. But that in itself is pretty easy, and you can even do this today. But the real kicker here is that will also allow you to query these columns as like completely normally with all your, the link operators that you love, where and order by and whatever. So you'll treat that array exactly like you treat any other collection that we already have in EF Core, which is like a pretty big thing. And we also will support parameters of that thing and constants. So basically lists of arrays inside your query, which are completely queryable. So this is basically a major upgrade to EF Core's query pipeline that unlocks a lot of patterns. And one of the things that this unlocks, which is where this all kind of came out of, is what happens when you do contains over a parameter. Our second most highly voted, or is it the first? I don't even know. Highly voted issue on our repo is when you do contains over a parameter, then we currently take that parameter's values and we stick them into the SQL, and that creates loads of performance problems with planned cache because your SQL is different for every query. It's really bad. And this solves this. This will basically pack all your, your parameter data as a SQL, as a JSON string, send that to the server and unpack it there in SQL. And that's basically how we're solving that problem, which is like it's been a big problem in EF performance like over the years. So I'm very happy we're finally doing it. And I'm excited to see what people do with the new querying capabilities as well.
And since I know you talked about this, so talk about Postgres.
Yeah, it's a good question. So the same concepts, in fact, the same feature primitive collections maps to Postgres via the arrays concept. So Postgres has supported native arrays already for a long time. The provider, so the database supports arrays for those who don't know it, and the provider has had support for them. What I'm doing in the process of doing is mapping this new support in EF onto the PG feature. It's fascinating. It unlocks new things also in PG array support. So, array support existed in Postgres, but you didn't have the option of arbitrary querying over these arrays. You couldn't start doing, some array property where something .order by .join with something else. And now you're able to do this. So this is a game changer also for Postgres. Of course, the native array support makes it better than having to, serialize a collection into JSON as a string, send that string, have it like parsed and, unpacked. All that has some sort of overhead in terms of performance, but I suspect it's going to be pretty good also on the other databases as well. So yes, Postgres as always will be, a little bit better, I think, but yes, it will be very cool. This already works also on SQLite. It works on SQL Server. It can work on MySQL as well. I've done the research for that. So this is going to be a very cross-cutting kind of feature across databases. It's very cool.
Good stuff. Okay. Also, so it's been a month since we did a community stand-up because we were not available a couple of weeks ago. So some stuff that happened around that time, I did a major overhaul of relationship mapping docs, which then Shay had to review these 8 new pages of documentation. We have so many examples in this now. So 12 examples for one-to-many relationships, 13 for one-to-one relationships, and 16 many-to-many relationships. So whether you've got foreign keys, you've got navigations on one side or the other, you've got an alternate key, a composite key, all of these different things. You're mapping the join table directly. You're not mapping the join table. You've got a payload in your join table. All of these things, we've got examples on there, and all the code is obviously on GitHub as always, and you can download it and run it. And then there's also just a lot of information on using different kinds of keys, foreign keys, primary keys, and alternate keys in relationships, how you configure navigations, and then some details about what the relationship mapping conventions do, which kind of overlaps a bit with what we're going to talk about today, as does how you use mapping attributes or data annotations in that. So loads of good stuff there. We've also included a glossary of terms. So when I say unidirectional relationship, you know what I mean. There's also some updated docs on scaffolding, reverse engineering. So we've got some better docs on handling connection strings, and in particular how you use user secrets to manage your connection strings, both in EF Core, but also specifically when you're doing scaffolding. Some clarification on how it works for selecting tables, views, and schemas, and the interactions between those flags, which was a little confusing. We've got some examples of what it means when you say use database names, because that again could be a little confusing. Showing how we scaffold many-to-many relationships, some details of how C# nullable reference types are used in scaffolding, and then some kind of conceptual documentation on different approaches to using scaffolding as an ongoing process in your application development. So that's State of the Unicorn. And unless there's any questions on that stuff, we'll go straight into model building. Okay. So what I have here is I'm actually basically in the EF Core code. So this is, our GitHub repo. And I've essentially created a unit test project here. which has one test in it, and this just makes it easy for me to debug into the code. It's all in one place and everything. But the unit test, all it does is create a context instance and then do some stuff to build a model, so we can see what happens. The model, the context, it's got 2 DB set properties, blogs and posts, nothing unusual here. I also do a configuration of another entity type in on model creating, so using the model builder API. We've got some stuff in pre-convention configuration to configure the conventions, and then we've got a custom convention here to do that. And then these are our entity types. Fairly straightforward. We've got a data annotation on there, and that's all there is to it. So this will hopefully show us some of the things happening when we build this model. Okay, so I'm going to debug this unit test. Okay, so when does the model get built? Well, the model gets built basically the first time you use the context. So when the context gets initialized, it gets built. So you'll notice that we hit this first breakpoint without going into any of the model building code, because the context instance is created without initializing the context. And so when you create a context instance, it doesn't build the model then, it builds it the first time you use it. And so what we're going to see is that if I actually run here now, so we're going to add something to the context. In order to know about this entity type, we need the model. So that's when it's going to be created. And indeed, I ran this, and we're in context service initializing. If you want to know more about this part of it, we did a community stand-up last year on the internals, or what happens when you initialize a DB context, and we went through how all of this stuff works. But fundamentally, this is just going to create the context service and then initialize things. And as part of that, we will access the model property. So this is the model property on the DB context, essentially. So it's actually in DB context services, which is owned by the DB context. But we're going to access this, and when it's not initialized, then it will create that model for the first time. Okay, so let's see. Not sure. Did I do something there? Yeah, it's not doing what I thought it was going to do. Okay, let me start again. Let me run the test again. Debug the unit test.
I can do a little dance in the meantime, so
yeah,
that
no, it
keep
didn't.
our audience entertained.
Yeah. So what we should see is it going into the model building process. Maybe I evaluated something in the debugger and it skipped all that stuff. I don't know. Anyway, of course it's running much slower than it normally does because we're streaming. So it always doesn't normally take this long to run the test. Okay. Okay, so now we're in create model. So this is what happens when we need to create the model. And first thing we do is say just set a flag to make sure we don't do this twice, because if you try and recursively create the model while you're creating the model, everything goes wrong. So we stop you doing that, which normally isn't a problem. It's only if you do some weird things inside, like on model creating or something, that would happen. We'll get we get the model from DB context options. So when you do use SQL Server or something like that inside your on configuring or inside add DB context, you can use a pre-built model in there. And what this is doing is saying, is there a pre-built model? I was hoping to prepare an example of using a pre-built model, which I haven't got to because of the paprika and everything. But basically, it's not usually very worthwhile to try and pre-build a model, and you have to take into account certain things like making sure the correct conventions get used to build that model, and and then initializing it appropriately and everything like that, which is normally just handled for you by DB context. And as we'll see, there's a caching mechanism inside what we're going to look at today inside DB context, which means that you won't, not pre-building your model doesn't mean you will, like, it gets built every time you use the context. It's already efficient and cached, but you can set it on the context options, and this is just what that checking that's what happened, whether that's happened, and if it is, whether or not it's the same version, so we can tell you, hey, you built the model with this version, but you're using it with this other version of EF. Okay, so assuming we haven't done that, then we're going to try and get the model from the model source. This stuff here is also to do with compiled models. If you have a compiled model, which we've done a community stand-up on that last year, so you might want to go look at that, then you're going to skip a lot of what we're doing now because it happens in the compiling phase, and instead you just basically do the runtime model initializer to initialize the model for runtime. But in this case, we're not doing the compiled model. So now we're in the cache. So this is the model source, which, and in EF terminology, a source is something that combines a factory and a cache together. So it's a factory that will build, it contains a factory to build the model, unless it already finds one in the cache, in which case it takes it out of the cache. Okay, so we get the cache and then we get the cache key. Now the cache key is the thing that determines whether or not we should build another model, and it's determined from the context. And in fact, if we look in the cache key here, the default cache key basically has two flags. It has the context type, so some DB context, and then a design time flag to indicate whether the cache model is for design time. I'm not going to go into detail into the design time model. The design time model contains additional information that EF code doesn't need at runtime to, execute queries and updates and things, but it needs if you're doing migrations or something like that to know about, things on the table or on the, in the database that are specific to creating that database. So you need it at design time, but which EF core doesn't need at runtime. And we generally have an optimized runtime model that doesn't include those things. And that's kind of the normal process. But for certain situations, you need the design time model, and that's when this comes into play. But fundamentally, you get one model per DB context type. And this is the caching mechanism I said. So if I have my SumDB context, we're going to assume that SumDB context uses the same model every time it is used. And that context type will always use the same model. And that's the default caching mechanism. Now, in the model building docs, I'm just going to pull up here really quickly. Here it is. We have this documentation on using different models, and that uses this iModel cache key factory. And the iModel cache key factory can say, all right, so I can put some additional information than just the context type. So I can say, actually, for this customer, because I've got a multi-tenant situation, this customer has a different model than this other customer. And so even though they've got the same context, DB context type, I want a different cache key. Which, when you look in the code here, makes sense, right? This is basically getting the cache key factory, and then it's looking at that to see whether we should use the existing model or create it. Okay, let me know if we should stop for any questions?
No, I don't think so.
Okay, I
think we're good. I'm handling various questions.
Okay, so we haven't got the model in the cache. This failed because we haven't built it yet. We then do very often when you're caching something in a thread safe manner, you have this mechanism whereby if you don't find the thing, then you build it, and then you look and see at the point when you finish building it whether the thing still exists, and if it does, then you throw away what you've built. This is a very common mechanism when you're doing thread safe code, and this is in fact what dictionary does by default. The idea being that blocking in order to wait until the thing is built is generally less efficient than potentially building the thing twice by 2 different threads and then throwing one of them away. In this case, we don't want to do that because we want to make sure that the on-model creating code is really only called once, because it is not thread safe, or it may not be thread safe, and that can cause issues if you've got 2 threads calling the same code twice. So we actually take a proper lock here, which means if another thread comes in and hasn't found it, it's actually going to lock. And then we do essentially this double check locking thing where we try to get the value again. And this ensures that we're only actually ever going to build the model once, even if multiple threads try and use it at the same time. Did that make sense, Shay?
Sure. Though my attention is split with the
Okay.
answers, but I
Okay.
am listening.
Yeah. So now we get to the actual guts of creating the model. So in this is the create model method. We're still in the model cache at the moment, but this is where we've actually come down and said we're going to build a model now. So the first thing we need in order to build a model is actually a convention set. So what's a convention set? So as you are probably aware at this point, model building uses a set of conventions that determine how entity types are mapped, how relationships are configured, how various things in the database work, such as store generated keys and things like that. And a convention set is the set of conventions that work for a particular database provider to make the model that's appropriate for that provider. And that consists of essentially 3 different types of conventions. Provider-specific conventions, so in this case, specific to SQL Server, ones that are common to all relational databases, and ones that are common to any type of model you're building for EF Core. So we're going to step into this and see what that really means. So we have this create convention set method, and it's going to call create convention set on the builder here. And now we're into the code, which is actually going to create the convention set. And you'll notice where we are here is in the SQL Server convention set builder. Again, I refer you back to the talk we did last year, where we talked about the internal service provider and how different database providers can override services in the internal service provider. This is what's happening here. When we set up the internal service provider, the SQL Server set up the SQL Server convention set builder in order to make sure it got the SQL Server conventions. And it derives from relational convention set builder, which itself derives from the provider convention set builder, which is the base one that sets conventions for any provider. Okay. So if we go down here, let's actually step into this a little bit. We can see we're adding conventions here. So we're saying, oh, actually, I messed up there. I was supposed to go down into the create convention. And rather than stepping into it, I'll just show you it. So the first thing we do in the relational one is say, call the base one, right? And so if we go to the relational one, start again. The first thing we do in the SQL Server one is call the base one which is the relational convention set builder. The first thing we do in the relational one is call the base one, which is the one that's common for all of them. It's common for all of them. We create a new convention set, empty, no conventions. And then we add all of these conventions. And all we're doing in this case is adding, because there's nothing to replace, right? And these are things like, max length, precision attribute, relationship discovery, key discovery, all of these conventions, which we'll look into a little bit in a minute.
So just so that people to have a very concrete thing in mind for people. So you know how EF Core recognizes, for example, the max length attribute that you can slap on your properties. There's a pluggable piece of code, the convention. That's exactly that kind of thing. There's a pluggable piece of code that does this, that scans the properties in your model, which you've added to your model. And when it sees a max length, it reads it and it puts that information in the model. That's the important part of here is that it's pluggable. This is not something that's hard coded into EF. You can remove it. A provider can add something, and that's super cool. Like if I'm the maintainer of the Postgres provider, and I want to add a feature where, I don't know, there's some attribute I invented in my thing, and that has, if some user puts it, then that impacts your model in some Postgres specific way, then I can do that very easily. I just add a convention in the Postgres convention set, as Arthur said, in the provider specific one, and that will run along with all of these. So that's a very nice idea of how EF Core works, is these pluggable pieces of logic to configure your model.
Exactly. So let's actually go look at that. So this is, like I said, this is the base one. Okay, and this was called by the relational convention set builder. So when this returns, the relational convention set builder does two kinds of things. First, it just adds a bunch of new ones, things that are only specific to relational. So stored procedure convention, for example, there aren't stored procedures other than in the relational level, and so that's where it happens. So these are all just specific relational conventions. It also does this thing where it does a replace. So it's like, okay, so I'm going to replace the value generation convention that happened at the base level with one that does more specific stuff for relational. And it does that with a couple of things here. And then this thing finishes, and we go back to where we started, which is the SQL Server convention set builder. And this really gets into what Shay was saying, where the provider can change it. Again, it's adding a few conventions that are just specific to SQL Server, memory optimized tables convention, for example. But then it's also doing this replace on some of the ones that were even done in the relational or at the core level. So an example of this is the store generation convention, where this is going to say, okay, I can support identity columns, which are kind of a SQL Server thing, or I can support sequences, and this is what I'm going to do specifically like that. Or the cascade delete convention, where SQL Server has some kind of funky behaviors in its cascade delete that's very specific to it, and so it has its own convention that replaces the default cascade delete that's in there. And then there's also some mechanisms for being able to insert conventions before or after other conventions, which is rarely important, but occasionally important for making sure that things happen in the right order. And so in this case, we want to add this convention before entity type change annotation occurs. And Andrew's really the only person who fully understands the ordering of some of these things, but most of the time it's just adding and replacing. Okay, so we've done all that, and let me step out of here. We've done all that, and we've got a convention set. Okay, that's the convention set for the database provider that we're using, which is almost everything that we need to build the model. There's actually two other ways that conventions can get added to the set of conventions that we use. And the first one of these is from plugins. So if I go back to my test and bring up the context again, so you'll notice here I did use lazy loading proxies. So this is a plugin. This uses the the proxies plugin. You're all aware that you can actually tell it now in EF Core 8 to ignore non-virtual navigations, which means even though I haven't got virtual navigation properties on here, it's not going to throw, which means I could be shooting myself in the foot because they won't lazy load. But I'm okay with that, because the only reason I wanted to include it at this point is to show that when you put a plugin like this, the plugin has an ability to add, change, replace conventions. And that's what's happening here, where we've got this list of plugins, which contains hopefully just one, the proxies convention set plugin. And it's going to go through there and it's going to say, okay, given the convention set, you go modify that thing however you want. And so it's now going to do a couple of things on it. It's going to do an add after, we saw the add before and thing before. So it's going to say, okay, I want to do a thing which is going to set up change tracking that works for proxies, and then I'm going to use this proxy binding rewriter, which tells EF, instead of calling the constructor to create the entity instance, call a factory method, in this case in Castle Proxies, that will create the proxy instance. And so it's actually binding that into the model. And so these are added as conventions that run when you build the model, so that then at runtime, EF knows, oh, this is the code I need to call to create an entity type instance instead of that code to create an entity type instance. So that's how a plugin can affect the convention set. Okay, so we've got the basic convention set now. And this is now, remember I said there were two other ways conventions could get modified. So this is now the way applications can change the convention set, which we've shown before. We've got a full stand-up on this. But basically, we're just calling this configure conventions method that I'm sure you've seen on your context instances. And so this a couple of things that this can do in general. One is you can use the configuration builder to say for all properties of type string, set them to Unicode, to not be Unicode by default, or you can add your own convention in here. So in this case, we're saying we've got a max length string convention, which is in the docs as one of our conventions, and we want it to make all strings, instead of nvarchar max, make them nvarchar 124 by default. We'll actually see later on how when these get executed as part of building the model. But this is how this configure conventions is called configure conventions, because that's what it's doing. At the end of building a convention set, you're now configuring those conventions and changing them in various ways. So this is, note that this is happening before we built the model in any way, right? So it's not, there's no iterating over anything that's in the model and setting is Unicode to false here. This is just saying, change how the conventions are going to work, so when I do build the model, these things happen, which is a pretty powerful way of doing it. And in the docs for this and in the stand-up we did on that, we talk about why that's important and how you can really make use of this. Okay, so let's get out of that. Okay, so we've got our model dependencies that contain our convention set now. So now we're going to create the model builder, which is where all of the meaty model building stuff happens. And it's in the constructor for the model builder where we actually create your model for the first time, and we pass in the conventions. So the model knows about the conventions. This is actually not the runtime model. The runtime model gets created later and it's optimized, but this is the kind of normal model that's used when building things. Okay, so we're inside the constructor for the model now, and we create this convention dispatcher, which you don't need to worry about too much. And in fact, I couldn't talk about in detail. Again, Andrew's the one who knows about this, but it batches things together and does stuff to make sure conventions run faster than they would otherwise do. And then we create a builder. And this internal model builder is essentially the thing that is orchestrating the model building kind of under the covers of the public model builder that has all of the kind of nice API on it. Okay, so we've done that. And we then call on dispatcher, so this is the convention dispatcher, on model initialized, and this is going to run the first bunch of conventions, which are the I model initialized conventions, or initial whatever. It's basically going to initialize the model by running a set of conventions, and that's what happens. That's the whole thing now is driven by the conventions. We haven't got any model. There's no model right now, and the whole thing is driven by these conventions. So to going back to Shai's point, this is all pluggable. This is not hard-coded. You can replace, change any of these conventions. I'm not saying it's easy to do that, and there's a lot of interactions between them. There's coupling happens when you do these kind of things, but it's a very powerful, flexible mechanism where you have the ability to derive from one of our conventions, for example, and just tweak the behavior of that. It's all there in a kind of pluggable way, which ties into kind of the whole internal service provider mechanism, the whole way that EF is constructed to be, this extensible, pluggable mechanism. Okay, so let's run here. And one of the very first conventions that runs, if not the first, is the DB set finding convention. So what's this going to do? Well, you can probably guess. On our context, of course, we've got 2 DB sets, and these are going to say include blog and post in the model. And the DB set finding convention does that, and it uses this service again, using a service out of the internal service provider, the set finder, which finds sets on the DB context. If we step into find sets there, Define sets. You can see that this thing has a cache in it again. The reason being, we actually typically find sets for two different reasons. We find them in order to initialize the DB set properties, which we went over in one of the other stand-ups on the context initialization. And then we also need that same information now to build the model. And since the code to do that is reflection, which is inherently not that, fast, and we want to use it again and again, or especially not just for model building, but for initializing sets and everything, we cache the DB sets. So in this dictionary, we actually already have the sets that have been found on the context, and then we go through each of those and just call the entity method. Now it's a non-generic version, but this is the same thing essentially as when you were in the model builder and you do .entity block. This is basically the same thing. It's interesting. I'm going to ask Andrea about this, that we consider that sets properties are configured with a level of annotation, which
Well,
is kind of,
it's not in the Fluent API, right? I mean,
it's not, no, but it's interesting that it's not fully by convention either. It's like, so I don't know. Anyway, it probably doesn't matter. I was just surprised that when I saw it, I thought, oh, that's kind of
so just to
interesting.
make sure everybody hearing us understands, this is literally here the code that scans your context, finds those DB sets which are eligible, and says, okay, the user has these DB set properties. We're going to add those types to the model, and this is why you don't have to do this yourself. Otherwise, we could have asked you to list out in your on model configuring, I want this entity and this entity and this entity. This code does it for you by convention. Okay, so I think that's a great example of a convention. And you could override this, for example, and say something like, I don't want to add DB sets whose name starts with X, or with an underscore. Have some sort of convention of your own, and ifcore allows you to override this convention here and do exactly that if that's what you want. So I hope that gives you guys an idea.
Yeah. Okay, so let's see what happens when we go into this method. So we've come through a few levels of interaction, and now we're in the entity method. And there's a lot of stuff goes on here to say, have you already ignored this, so that we don't want to do anything here? Should we be doing something with owned types? So we've got a configuration type here that says it's just a normal entity type. And then we start this delay conventions thing. This is the batching thing that Andrea understands. And then we're looking for a shared type entity type. Is it named? Well, it isn't, so we're good. Does it have a CLR type? Yes, it does. The CLR type is blog, so we're going to use that. Does it have a shared configuration source? No, it doesn't. All of this is complex stuff, but it's doesn't matter for the general kind of concepts that we're going for here. Okay, so now we're saying, okay, we've got a type. Let us actually create that. So we're going to call this add entity type. So this is now the low level metadata. So when you're using EF models, you have the model builder API, which has this Fluent-like API interface on it that lets you do things in a Fluent manner. Underneath, there's this metadata, so the I model, the I entity type, the I property, all of this stuff, which is actually what you get from when you do context.model. And it's this that actually contains the metadata, the normal model construction, the metadata for it. And so we're going to call add entity type to do that, and then we return that. Now we'll do this for each of the entities that we found on the set. So that's now doing it for post. Step out of that, and an interesting thing happens when we've done that. So we're now going to basically, sorry, I've just got to get through the rest of these things. So it's doing additional model building conventions. Let me step out of that again. Okay, so what happened there? Once we'd finished doing that, it said, okay, I've saved up a bunch of conventions that now need to run when you add an entity type to the model. And this is again, what Andrew understands, this is the convention dispatcher thing. But the fundamental thing that you should understand here is that the conventions are reactive. So when I do something that adds an entity type, it then triggers additional conventions that implement the interface for when an entity type has been added. So in this case, the entity type added convention. So it says, okay, once an entity type is added, I need to do some additional stuff for it, right? I need to find out things about it. And indeed, if you look at the entity type right now, if I do the debug view for blog here, yeah, you can't see that, can you? Let me get something that's going to be a bit easier for you to see, to paste this into. Oh, not that. This. Oh, it was that. Okay, and let me make that bigger. Okay, so this is the debug view of what we have for the entity type block, and there's some things to notice about this. It's keyless. Well, we know that it's not going to be keyless. We have an ID property, right? But that hasn't actually been discovered yet. The convention to discover the key property hasn't been run yet. And so we don't actually know the ID is the blog's primary key property. Likewise, it doesn't have any navigations yet. We don't know about that it's related to blogs. All of these things happen by secondary conventions running after we call after the entity type's been added, and we call the entity type added convention. And the one I'm in order to show you this is key discovery convention. So this is key discovery convention, which again, you can override and change the way we discover keys. Although we have an issue to make it a little bit easier to do that, because some of this code is not that easy without like copying and pasting a lot of our stuff. But basically, we're going to get a bunch of candidate properties and determine which ones match our convention for keys. And if we look at the result here, we found one property, blog ID, matches our convention. So if a property was called blog ID as opposed to blog.id, that would also match our convention. And if the ID was uppercase, there's various conventions, right, that will match a primary key. But in this case, we've called it ID. We found one that's ID, so we said, okay, we've got one. If we don't find any, then we go in and do some other conventions that are running specifically for many-to-many that we won't go into. Otherwise, we found these key properties. So we go back to here where we've called discover key properties, and we say, okay, if there's more than one, we don't know. You've got a blog ID property and an ID property. That's ambiguous. We're not going to just arbitrarily choose one. So we throw a logger thing saying, "Oh, we found the wrong one," and we return, or we don't know which one and return. Do some stuff around ownerships. Otherwise, we say if it's 0, again, we don't know. So we're going to do some stuff there. Otherwise, and I actually don't know what this code here does. I was going to ask Andrew. I was looking at this earlier. I'm like, what's happening here? I don't know. Anyway, the end result is we end up with, if I get over this, yes, we end up with key properties, and we say, okay, let's process the key properties, which will set the key. So we don't do anything. Oh, sorry, it's here. So here we call primary key on the entity type builder, and this is essentially the same as calling the has key on the Fluent API. So again, in the same way that when we discovered the DB set, we did the same thing as calling .entity on the model builder. Here, when we discovered the key properties, we're doing the same thing as calling has key, and we're saying it has the ID property. Although it will be set by convention, which means later on, if we find a key annotation or we configure it explicitly, this will be overridden, and we'll actually see that for foreign key later.
I think maybe you're already planning to do this later, but I think that's a great opportunity to talk about the 3 levels and the overriding thing. We also just had a question on that, about that.
Yeah, go for it.
Okay, I can do this. Andre, by the way, is in the chat. I'm a bit stressed because he's the final authority on all this. And if I say something wrong, anyway, anything Andre says in the chat is the answer to everything in life.
Yes, definitely.
Concerning model building in EF in any case. So basically, the thing is, we need a form of precedence in the configuration, right? The problem is we can't just have stuff configure things like at the same level. EF supports 3 levels of precedence and or overriding. First, you have something that some convention sets, right? That's, let's say, the default thing, the by convention behavior. That's the thing that you get if you haven't, as a user, done anything or specified anything. We love that, by the way. I'm kind of doing a segue. We think in general that you shouldn't need to explicitly configure your model, except if you want to do something very specific. So the ideal model, the ideal pattern, in our opinion, is that you follow certain conventions and you don't need to do anything. For example, as Arthur just showed, if you have a property called ID, that will be picked up as your key. It will also be picked up as as a serial, as an auto increment column if it happens to be an int on a certain type of database. So all that stuff happens completely by convention for you. And we know we occasionally see users who don't like this idea of conventions and have to go and explicitly do everything explicitly, right? So they go and they say, my ID property is a key and my other ID property on the other entity is also a key, although the convention will do that for you. You don't need to do this. So that's just a general thing. But all that is the default by convention behavior, right? Then when you start, you as a user start configuring your model, that obviously has to override whatever happens by convention, right? That's completely clear. You've got the defaults, but you want to do something else because you're the user. You're the one, determining, configuring what the model is. And here we have a split into 2 things, into 2 layers as well. Layers is maybe a bad word here because it means something else, into 2 types of config. You can use data annotations or attributes to specify certain things. So that's basically you going on a certain property in your model and putting something like max length or key or any one of those attributes which you see, which are data annotations. But then you can also go into your on model creating and use the Fluent API. So you can go to the entity and say has key this or set the max length via that, right? So you have these 2 things. And the question is, what happens if you do both? Because you can do both, right? So, I think the answer, the desirable behavior is pretty clear, right? What we basically do is whatever you do explicitly in the Fluent API is going to override your data annotations, right? So your data annotations are at a lower level of precedence. Because you may want to tweak so the data annotation is something you put on your, on your property and it's there and you can't really do anything. Whereas with the Fluent API, you can do stuff like you can even do an if, you can do a condition, you can check if some sort of condition is true, only then configure it as max length, only then override maybe that attribute which you put on, right? So there's this hierarchy where the Fluent API is your ultimate way of overriding everything. It's at the top, right? And it overrides everything below. So you have 3 levels. That's pretty crucial to understanding how EF Core managed this. Convention, data annotations, Fluent API, and that's how it all works. And it might also be worth, because I saw another question, somebody was a bit confused about this as well. Even if you have in your Fluent API, you're configuring things multiple times, like the same property. You're saying, oh, this property has a max length of 5, and then the same property has a max length of 10. That's not a problem. We don't view that at all as a problem. In fact, in complicated applications, you have layers of, you have this part of your code which does some model configuration, and then some other component does another. And it could very well be that this part configures this, and then that part goes and configures that as well, right? And that's totally fine. It's not an error. And the later configuration will simply override the previous one. And as Arthur showed you, I think you guys are starting to understand, every time you do something in your explicit API, that triggers off that whole cascading effect of conventions, which fire reactively, as Arthur explained, and cascade in your model and, propagate those changes wherever they need to go in your model at that point where you're doing this. So if you're overriding it later, you're re-triggering those, those conventions. That's basically how the whole thing works.
Yep. Good stuff there. Yeah, so just to add a couple of things to that. So on the data annotations mapping attributes, one of the main reasons that you may want to override those in your Fluent API is because they're used by many different things. So you may have required on your property in your model because you want it to use that for validation, for example. But that doesn't necessarily mean that you want to use it in the EF model to make the property non-nullable. You might, for whatever reason, still want it to be nullable in the database. And so we allow you to have the data annotation and then override it so that because the data annotation could have different usage in different places. And sometimes those things have slightly different semantics, like whether or not they allow empty strings for required, which is different between validation and EF core by default. And then a great example of the overriding existing Fluent API with custom Fluent API is if you use ASP.NET Core Identity, where it has a model for users, permissions, and all of that stuff, and you call on model creating on that context, and it does a bunch of Fluent API to configure stuff. But then you want to tweak it, so you want to actually change the max length on one of those things. Then you call it again, and it will override. So that's an example of using that. And then going kind of back to the beginning of what Shay said on the conventions, and let me just go and bring up the convention set here. So if we look at the convention set builder, nope, that's the wrong one. It's the provider convention set builder. There's a lot of conventions going on here. And especially in the early days of EF and Code First, we had people saying, I don't want any conventions. I don't want you to do anything that I haven't explicitly configured on the model. I want to control everything. And I can see why people might want to do that, because they don't like the idea that something behind the scenes is magically doing stuff for them and they want to have complete control over it. The problem is, I'm going to go out on a limb here and say nobody, other than Andrew probably, nobody knows everything that all these conventions do, because there's so many different things that you can change. Like EF has such a whole range of configuration that you can change, that understanding what it did by convention is not trivial. And if you're saying, oh, I actually want to explicitly configure all that, you suddenly find yourself having to configure things that you never even thought you'd ever want to change. And that's kind of the point, right? If you never thought you ever want to change them and it's always doing the right thing, then you don't even need to really know that that thing is done by convention. It's when EF does something that you don't want it to do and you say, oh, why has it done that? That's when you go in and change just that bit. But you don't throw the baby out with the bathwater and say, stop doing that for everything. And a simple example of this, which people often overlook, is configuring a relationship. EF discovers relationships by convention. So on my model here, that I have, where I have a blog and a post. So this navigation property points to on the post points to the blog, and on the blog points back to posts, and foreign key this is all discovered by convention. But people are like, I don't know if I trust that. So they write the full configuration, has one with many, has foreign key and everything, which is fine, right? That's not saying that you shouldn't do that. It documents what you want to do, it's very clear, but you're not fully configuring that relationship when you do that. You're still using conventions. You're still using a convention that says the key on the other end of the foreign key is the primary key. I don't want to use an alternate key. So that is happening by convention. Otherwise, you have to put has principal key on there to configure that by convention. You're still getting cascading conventions by default. You're still getting whether it's a required relationship and the foreign key is nullable, whatever, by convention. All of these other things are happening that you're probably not even thinking about. And that's the point, right? We don't want you to have to think about, oh, yeah, obviously, when I've got a blog and I've got a blog ID, I want this blog ID to match this thing, this key, the primary key on blog. That's obvious, right? Yes, it is obvious. That's why you don't think about it. But if you didn't, then you should change it. So does that make sense? It's like trying to think about it is like, I'm actually going to understand everything that's going on and doing by convention in the model is not an effective manner. It's much more effective to learn as you need it. When you run into something and you say, oh, actually, I've got an alternate key on the block, and I want this block ID to point to the alternate key, not to the primary key. That's when you do the configuration for it, and that's when you learn about the configuration for it and you override it. If you don't ever do that, which a lot of people won't, then you don't ever even really need to know this happens by convention. So anyway, I'll get off my soapbox now, but that's let's go back to the code. Okay, where were we? Oh yes, we were configuring the primary key. Okay, so we've done that, and we're back in the dispatcher here where it's processing the entity type added conventions, and there's various other ones that happen there, but I'm not going to go through everyone, so let's just step out of here. Now we've got to another interesting one. So this is an interesting one for discovering relationships, which ties in with what I just said. Okay, so by convention, we're going to recognize that blog has a post navigation that says it contains a collection of posts, and post has a blog navigation that says each post is related, each post is owned or related back to that blog, and there's also a foreign key convention, and this is happening as part of relationship discovery. And so if we look in the entity type builder for blog right now, and I'm going to do that thing again where we look at the debug view. If anyone from Rider is watching, the fact that this shows up in really tiny text while I'm on presentation mode is not cool. So, so I'm going to copy and paste it in trusty Notepad++ here. Apparently I missed the E. Let's put that in. Oh no, it's there. Okay. Okay, so notice now, before we didn't have the key, but now we do have. It's not keyless anymore. ID has been recognized as the PK. We've configured a key key, but there's still no navigations because we haven't run relationship discovery to find the navigations. We do actually have this annotation that we're using to do some housekeeping, which is like candidates for things that might be navigations. And I think Andrew would be the one to know more, but I think that's kind of a perf thing where we don't want to rediscover these things all the time. So we discover them once and then we store them while we're building the model on the entity type. But essentially, this thing is then going to run, and I'm not going to step through all of this stuff. But if we go now and look at the debug view again after this thing is run, if I can find it, here we go. We're going to see, let me just make that full screen. We're going to see that now, after relationship discovery convention is run, it's now discovered that there's a relationship to posts, and we now have an entity type blog that is related to posts. So that, again, that's a convention that's running, and of course you can override that configuration as we were talking about, which we'll actually see a little bit later as well. Okay, so let's step out of this now. And let's step out of here and step out of the convention dispatcher. Okay, and actually I'm going to remove this breakpoint, otherwise we're going to keep discovering key properties at various times. We've done that. We don't want to, let's not look at relationship discovery again. Okay, so we've now got back to yes, so back to the entity methods, and we're stepping all the way back out here. Okay, I'm just unwinding the stack basically at this point. For relationships, step back out of that. Step back out of that. Okay, so we've got to the point now where we're actually processing the properties. So one of the conventions that runs, so we looked at discovering keys, and we looked at discovering relationships. We also discovered properties. And once we've discovered properties, we actually run some conventions on the properties that have been discovered. And one of those conventions, which we talked about earlier, was the max length attribute convention. And this is going to look at the data annotation. We actually have a base class for property attribute conventions. So these are data annotations that live on a property. So that might be max length, required, Unicode, all of these things. And there's a base class here which you can use. So if you create your own annotation or your own attribute, mapping attribute, which is not that difficult to do, you can then derive from this abstract base class to handle most of that stuff for you. And if we look through if we go back down the stack trace to see what's happening, so this is the process property added. So we know we've added a property, and we know the member for that is title. So we've got title, and then we found in the next method, we actually found the attributes on it. And in attributes, we had a max length attribute. So we found that just using the get custom attributes method, normal thing. And then we're going to call this process property added, which is a template method in the abstract base class. And that's what's implemented in your own property added convention. So in the max length case, all we do is say, okay, look at the length on the, I need to go back here, look at the length on the attribute, and it says 100, and then say, okay, let's call has max length on the property builder, which is again very similar to what would happen if you were in the Fluent APA and you said has max length, except we pass in this flag saying it's from a data annotation. So now if I go into title and override that configuration, we know this came from data annotation, and we're going to replace it with whatever is explicitly specified there. Okay, so that's I can probably remove that now. Okay, so we've done property added. Let's step out of that. Step out of that. Step out of that. Step out of that. Out of that. Okay, where are we at here? Okay, so we've got to the point of on model initialized. All of that stuff happened on model initialized, and it was all driven by the DB set properties. Okay, so we had a DB set for blog and a DB set for post, and then we discovered those. We discovered the properties on them. We discovered the keys. We discovered the relationships between them. We discovered the data annotations and a lot of other stuff that we didn't go into. And we've ended up on the model builder with essentially a model at this point, which I'm going to show you. Let's look at the one without annotations on, because it's a little bit easier to see. Okay. Okay, so we've got blog and we've got posts, right? These are the things that were discovered by DB sets. In actual fact, I didn't need to have a DB set for both of these. One of these would have been fine if I just had a DB set for blog, because we follow these navigations. So we'd follow the post navigation, and because it points to blog, it points to post rather, we would then automatically discover post, even though we didn't have a DB set property for it, and it would discover that whole thing. So very often you don't, I think it's a common misunderstanding that you have to have a DB set property for everything in your model in order for it to be mapped, and you don't. And it's often better to think about the things that you actually want people to use at the top level to run queries on, for example, and only have DB set properties for those. Other things will then be discovered by convention because there's navigations pointing to them. However, we haven't actually discovered our entire model yet, and let me show you what I mean by that. How are we doing for time? We're only 7 minutes over on nominal time, so it's all right. So I actually have this admin post, right? Entity type as well, which I want to include in the model, and it has a relationship to blogs, but we haven't discovered it. And the reason we haven't discovered it is it's a unidirectional navigation. There's actually no relationship from blog to admin. There is a relationship, but there's no navigation from blog to admin, only the other way. But what we're going to do in on model creating, we'll see in a minute. In fact, if I run now, we should get here. Yes, so now after we've done model initialize, we're actually calling into the on model creating. So we've discovered the properties, we've run initialization. Now we're letting you do the custom configuration. In this case, I'm calling this entity method to add admin to the model. So let's do that. I can't remember if I need to step in here. I'm going to try stepping over and hope it works. Yes, it does. Excuse me. Okay, so we're in the same method we had before, entity. And we're going to go and I'm just going to step over all of this stuff. So this is adding hopefully the admin entity type to the model. And a lot of conventions will run as part of this, like we saw before. Okay, so now we've got an entity type builder for this, and we've got a debug view here. And we will see, if we look at this, you will see that we've now got the admin entity type configured. It's found its key. It's discovered that it's got a navigation to blogs. That's all happened. That's all happened by convention. And that's kind of important to see that, because we haven't actually, all we've done at this point is this top level call on the Fluent API. We haven't done any of this stuff, which is actually explicitly configuring that relationship. And so if we look in the model builder now and look at what that relationship looks like, let me look in the metadata here, debug view. Oh no, that's for the end. I want the actual model builder metadata. So where am I getting that? Model builder, here we go. So the model builder metadata. So this is the actual model as it's being built. And bear with me here. This will be interesting, I promise. Okay. Remember, we didn't have, oh, it's still not, no, it is in the model. We didn't have admin in the model before, but now it's added to the model. And we've got a relationship to blogs. And in fact, on blog, we have the inverse relationship to that, but there's no navigation from there. But the interesting thing is that we have created a foreign key for it, right? Because the relationship is actually going from the dependent in this case is blog. So dependent has the foreign key. And the foreign key is admin ID. And if we look at that, it's a shadow property. Now we actually know, if we go back to our configuration, that what we want is admin key to be our foreign key, right? We put an admin key property in there, but admin key doesn't follow the convention it doesn't match the convention for a foreign key for that relationship. And so we didn't discover it. And so because we didn't discover it, we created a shadow foreign key, admin ID, because you don't have to have foreign keys in your model. That's a whole nother discussion. But it's not necessary to have foreign keys mapped in your model. And so if we don't find one by convention, we create a shadow foreign key for it. And so that's what we've done here, which is fine, except now we're going to go in and we're going to actually explicitly configure the foreign key with this Fluent API. And what we'll see what, I think I'm just going to step over this and oh, I have to, got a breakpoint still there. But let's just let it do its thing here. And okay, so now we've let it do that, and let's just look at what's happened in the model from doing that. Find the debug view again. That, copy it and paste it into here. Okay. So we now find on blog that the foreign key is the foreign key here is admin key, because we configured that explicitly. And indeed, the admin key property is marked as FK. The admin ID property is gone. We removed it. So what happened here, and this is complex part of, that I've fixed some bugs in this, but it can be pretty difficult. What happened here was we added the admin ID property because we needed to have a shadow property for that relationship. We didn't discover. Once we knew admin key was the property to use for the foreign key, admin ID was now, we don't want that in the model anymore. It's superfluous. We created that by convention, and so we removed it and replaced the whole relationship essentially with one that uses admin key. And so that's a great example of how you're overriding the explicit configuration, and it's doing some fairly complex things in there. It's not just changing attributes on things. It's actually adjusting the structure of the model in order to now map what's happening. Should we have built conventions in this complex way? I don't know. That's a debate we can have. It's certainly powerful and interesting, and you end up with a model that's built as you're going along, which you can look at, and it's got all the stuff in it. If you are familiar with EF6 model building, it didn't work this way. It basically collected up a bunch of stuff and then applied it all at the end in a kind of opaque manner, which has some advantages too. But it is pretty cool the way this all works. And Andrew is the one who implemented all this stuff. So good work there, Andrew. Okay, so we've now done that. We've run on model creating, and we've basically created most of the model now. So we're back in the model cache factory, and we've created the model. What we haven't done is actually run what we call model finalized conventions. And those are running now. And remember the attribute, the configuration, sorry, the convention, the custom convention that we added, this max string length attribute, it's an iModel finalizing convention. To learn more about that, refer to the docs or the previous community stand-up on that. And it's now running its process model finalizing. And so it's going to go through, and for properties that it finds, it's going to set the max length to 1024, except, and let me put a breakpoint in here and run it until we find that title property. Let's see, property post content, title. Okay, so this property has, if we look at the debug view for it, it has the max length of 100, right? Because we put the max, not that. We put the max length data annotation on this, so its max length is 100. So now when we do call this has max length thing, because you're actually in the convention model builder that knows about these things, that knows this is running as a convention, it's not going to change. The max length is still 100. Why? Because the convention will not override configuration that's done by the data annotation. The data annotation takes precedence. Remember that thing Shay was talking about? The data annotation takes precedence over what you've done in the convention. And so when you write your custom conventions, you can do something like has max length, where it will set a max length for everything unless you explicitly configure it either Fluent API or by a data annotation, and then it'll leave it alone, which is a really great way of hooking into the way EF model building works, so that you can have conventions to do what you normally do everywhere, but still override them where you need to explicitly change that. So that's pretty cool. Okay, let's step out of that. We've done model conventions, model finalizing. Okay, and then we've now we're in this model thing where we model finalize, and at this point the model is actually the type of model is model. It's really the design type model that we're using to build everything. But then we do this make read only, which says, okay, this is now a finalized model that cannot now be modified. Like we've marked it as read only to say, if you try and modify it now, it's not going to work, because we're going to share it, right? And so we're sharing it between different context instances. All of those have to be able to access the model. If you start mutating it, then that wouldn't be thread safe, and it would also end up with race conditions like this context using it, and it's suddenly changed to that. So basically, it's marked as read only when you're done. Okay, and we then go through. Okay. So what are we doing here? We run a model validator. So there's a model validator that basically goes through and checks that your model is consistent and you're not doing things that are potentially either invalid or not recommended, and that can either generate errors or warnings in the log. Okay. If we were building the model for the design time, we would return it at that point because it contains all of our information that we need to do things like migrations, design time stuff. Otherwise, what we're going to do is create the finalized model, and I'm trying to remember where that actually happens. So I think it's here. So right, we've got the mutable model, which is a model, and when we return that, we've now created this runtime model. And I'm not going to, because we've already talked about lots, I'm not going to go into the details of how we create the runtime model, but it's basically a set of things that iterate over the contents of the model and then create an optimized version of that, which is optimized for reading and using at runtime rather than for modifying while we're building it, so that when you execute a query and we need to know the properties, you get that in a very optimized manner. And so that's why the type of this thing is now turned into runtime model. This is also what you get if you use compiled model. So when you do a compiled model, the compiled model basically sets up a bunch of code to create the runtime model directly, so it doesn't run all of those conventions, and that's why having a compiled model is much faster. And then we're going to return this model, and let me step out of that. Okay, so we're back here where we, in our favorite place, a model source, where we're caching everything. And we're actually going to set it into the cache, and then we're going to return it and finish coming out of creating the model property. Okay, and let's step out of that, step out there. Actually, let me just run to the next breakpoint. Okay, so now we've created the model when we added the blog to the context we need in the model to do that. So we created it. If we if we try and get that model from the context again, we now are going to find, oh, didn't do anything, right? Because it's getting the cache model. So right, so we did it once, now we're getting it. But more importantly, if we dispose of that context and then come in again and do context add again, so we still have to initialize the context. So we go into the context initialization code, but we don't actually create the model again. So we're going into
the most important part.
Yeah,
is not to do this again and again.
Yes. So here we are in the model source, right? This is the place where we cache the model, and we say, oh, it's there. It was in the cache. Just return it. So when we create another instance, we now are basically back out here, and we haven't run that all again. So, and remember we've got the context cache key that says for some DB context, we always assume there's the same model, but if you want to, you can override that and create, different models based on changing the cache key, so that you could have two different models, but you definitely would not want to create a model every time that you create a context instance, because you'd have to run through all of that model building code every time, and that would be a killer on perf.
This reminds me, sometimes we get users coming in who want to use EF in extremely dynamic scenarios. They tell us that they want to, I don't know, they want to build up their model in some way based on whatever, some configuration, and every single time they want it to be completely different. And I think maybe after having seen everything that happens when you build a model, you're getting a sense of why that's not a great fit for EF in general.
Yeah.
So this is not, a model isn't just like a bunch of tables. It's a very complex thing which needs to be built. It needs to be consistent, needs to be validated. There's a lot of complex stuff. You've only seen the tip of the iceberg here in what Arthur showed. So this goes together with the idea EF is a sort of, let's say, a statically typed like a framework at the end of the day, right? You have your model and the model is finalized, and then you work with that model, and you're not like adding another property after having started to work with the model. I mean, that just doesn't make any sense. A bit like how in C# you have types and you don't modify those types, you just work with them, right? So there's this idea, whereas if what you want is to do like a completely dynamic thing where you're changing stuff and so on, EF is maybe not the right tool for that. And now you maybe have a better understanding of why.
Absolutely. Okay, so that's basically what I had. I don't know if we had any questions we wanted to go back to. I think you and Andrea have probably been taking care of all of that, right? Shay?
Sorry, I'm still looking a little bit. No, we're good. Between Andre and me, I think we answered.
Okay,
We don't have any
so
outstanding questions.
yeah. Okay, so yeah, thank you for watching. We're 24 minutes over our allotted hour, which is fairly average for us, I think. So we're not beating.
Allotted now is a somewhat ambiguous term.
Yeah.
So
Anyway, so yeah, hopefully this was useful. We'll try and I think I'd like to do one of these on change tracking at some point, because we've kind of been going down the stack. So we'll see if we can get that at some point. We also have some guests coming on to talk about SQL Server at some point soon. So yeah, look for more as we figure out what and when we're going to do. So thanks for watching, everyone. Bye. Oh, I'm not ready as always with the we're done. Okay. Now really, bye.